Hello my fellow gnomes, my name is GnomeCode and today we're going to be making this round based system for a game. So you see I've got this little countdown here, and then when we reach the end we get into the game, we get 10 seconds, we can sort of move stuff around, disrupt it however we like, and then when that timer runs out we're going to get teleported back into the lobby area and the whole thing starts all over again. So if you want to make something like this for any kind of game really, you can use this for loads of different things, then watch along till the end, follow along, and I'll show you how you can make a little system like this. Okay, so I'm just in a blank base plate here. I've made it a little bit smaller and I've added in a spawn point, but that's all I have, no scripts, nothing. We're going to do this step by step. So we're going to ensure we have our output enabled. That's going to help us a lot. If there's any errors later on, it'll help us fix those. So let's create a script, add this into server script service. We're going to call this server. This is going to be the main workhorse where everything happens. Now, thinking about a round-based system is something looping, repeating, and of course in code we've got the perfect thing for this, which is a for loop. Now we're going to need a duration for our round and a duration for the intermission. So let's create some variables at the top here. So we'll have a local intermission time, and this is going to be equal to, let's say, 5 seconds. And the code assist is started. We don't actually want this. How does this needs to go away, please? There we go. Local round time, and we're going to set that equal to, let's say, 10 seconds. Now I've typed both of these in capitals. It's sort of like a convention in Roblox Studio scripting when you have something that we call a constant that you're not going to want to change during the program. So we set it at capitals, sort of a nice global variable. And then all we can do is we can say while true do, and we can have a little for loop. I equals, and this is the number we want the loop to start at. So we can start it at intermission time. We can finish it at the value of 1, and we can increment it by -1. So it's going to go down -1 each time until we reach 1. And then we can print out intermission and a little task.wait. And then after we've done the intermission loop, well, we're going to do the round time loop as well. So we can print out game and the value of I. So that is a really, really basic little round system, right? We've got 2 loops inside of a while true loop. Now, this isn't really going to do very much, but if we hit play right now, we'll be able to see down in the output here, we've got 5, 4, 3, 2, 1, and then the game 10, 9, 8, and so on. So now we've got our clock going, we can start to flesh out this a bit more, because we don't want to have everything inside of this while loop. It's going to get a bit messy. Let's break it down into some functions instead. So let's have a local function called intermission. We're going to have another local function called, we can call this run game. The reason we're not going to call the function game is because that is a highlighted keyword of Roblox. And then you'll notice that seeing as intermission and round game, we both have these for loops, kind of the same thing. We want a clock for both of them. We can actually create a sort of function just to do this. So let's create a countdown function too. And that'll have a duration as its parameter there. And then we can have a loop. So we can copy in our for loop and we can say for I equals duration, and we can maybe, we don't need the print anymore, but we can have that task.wait. And then inside the intermission, we can count down for intermission time. And inside the run game function, we will do the countdown, but this time it is the round time variable. And then at the start of these, we could do a little print. We could say intermission, and at run game, we could do another print, and we could say game begins. And so that's helping our code to be a little bit more readable, because now inside of while true, we can simply type intermission and run game. And so if we were to click run again, it's going to do pretty much the same thing. Intermission. We're not actually printing out the value of I. So we could have that there. We could print out I. Now if we run it, we'll see intermission 543 and so on. But if we don't want the game to start until we have enough players, then we're going to need to check the player count. So let's say we have local min players, and I could set this to 2 to require a minimum of 2 players. And then I'm also going to need the players service. So local players equals game get service players. That's that game global keyword I was talking about earlier that we can't use. It's highlighted in blue. And now once we've got the players inside of the loop, we can check if hashtag players, and we get the get players method, which gives us a table, and the hashtag is how many is in that table. If that is greater than equal to min players, then we will do the intermission and run game. Else, let's just print waiting for players, and we'll just check every second. So if I was to play now, we're going to get waiting for players. That's going to keep repeating. If I just change this to 1, for instance, then now if I join, it's going to start. So now we've got to check if we've got enough players in the game. Now, the next thing we want to do is want to teleport the player into a new area. We don't want to keep them in this boring lobby area anymore. So I've got some maps that I've already made. I'm just going to copy them over into the workspace. Here we go. They're in a maps folder, and I have a desert, an exoscape, and this garden over here. Now, in each of these little maps, we need to provide a position to move the player into it. So we could hard code the exact coordinate value, but that's a little bit tricky to do. Instead, the easiest thing to do is place a little part, and you can resize that wherever you like, and you want to position it where you want your character to be teleported to. So we'll set the transparency to 1, and we'll name this thing spawn. My head's probably blocking this a bit, so I'll move my head out the way. There you go. And we'll call it spawn, and we'll make sure the can collision is disabled, and we'll anchor it as well. And then once we've created our spawn point, we're going to drag that into, so this is the exoscape map. We drag it in. You see I've actually already got one. I created one earlier. But so we have now this little spawn point. It needs to be called exactly spawn with a capital S and then lowercase rest of it. And if I look inside my desert map, I've got one called spawn as well. And I've got one in the garden too. So let's see, I've got all of these little parts. And that is where I want the characters to be teleported to. That's very important. Okay, so heading back into our server script now, and we're going to create yet another function. And this is going to be the teleport players function. And as the parameter for this, we're going to be expecting the C frame that we want our players to go to. Oh, let's make sure this is a function. There we go. So what we need to do is we need to grab all of the players. So we'll say local players equals, and we use the player service, and we're going to get players like we did before. And then we just want to loop through all of those players. Now, sometimes a player's character won't actually be fully loaded in. They might have just joined the game and their character might not have spawned. So if they don't have a character, we can probably just ignore them entirely. So if there's not a player.character, then let's just continue and we'll forget about that player. But if they do have a character, then we can say that their player.character, and we want to pivot to, in other words, want to teleport them to that C-frame value that we're going to send to this function. So now we can call our teleport players function from the intermission and the run game. So at the intermission at the very start, we want to teleport everybody to, and this is essentially just going to be the spawn location. So if I go workspace.spawnlocation.cframe, And then I want to offset it a little bit so they don't get teleported directly inside of it. So I'm just going to add an offset of cframe.new 0 to 0. Let's zoom out a little bit. You can see that whole line right there. And then in terms of the run game function, later on we're going to randomize the map, but just for a second, let's say our spawn location is going to be equal to workspace.maps.desert.spawn.cframe. And so then we can just pass that in again if we say teleport players spawn location. So now let's play the game and we're going to see what's happening. We've got in our output 5, 4, 3, 2, 1, and we get teleported over to the desert area, working successfully there. The game countdowns to 10 seconds, and when the timer finally runs out, we should get teleported back to the lobby. Cool, there we go. So this is working pretty nicely, but the only problem here, obviously, is if I'm moving these boulders off the map, and they're all in workspace all the time, these maps, so I can see all of them. And if I'm to destroy any of the things in the level, they stay destroyed. So ideally, we want to move all of these maps into replicated storage and then just create a copy. Just copy it, move it into the workspace. Players can play about with it, and then we can just delete it when we're done. So inside of our little while loop here, let's go and grab a map for ourselves. So first of all, we're going to need to access that replicated storage. Let's get the service for that. So right at the top of our script, local replicated storage equals game get service replicated storage. And then we can go about grabbing the maps. So local maps equals replicated storage dot maps. We want to get all the children. So all of the 3 objects inside of it are going to get added into a table. We want to find ourselves a random map, which we can do by saying the table, and then we use these square brackets to get an index from it. Do math.random with the argument being the number of items in the table. So essentially just getting a random number between the contents, which in this case there's three items, so random between 1 and 3. And so once we've got that random map, we know that our new map for this level is going to be equal to random map. We will clone it, and then we can set the new map.parent equal to the workspace. We can send the new map to run game, and just before we run the game and start teleporting all the players, it's probably a good idea just to wait for a second for it to load in a little bit more. But then we can send it to the new game. We can expect it here, the map. Let's just say map. And this time, instead of our hard-coded spawn location like here, we can actually use that map value. So we know that all of our maps are containing that spawn object that we just created. So we can say map.spawn.cframe. And in fact, we probably don't need to have this on a separate variable anymore. So we can pop that down there, delete this line. And if we just test this real quick, we've now got nothing here, and the server should decide a random map for us. So what we're going to get, we're having the desert loaded in, funnily enough, and we wait for ourselves to go back to the lobby. And this time we've got the alien map, but we haven't cleared up that desert map either. So let's just clear that up quickly. So at the very end of the countdown, we should call map and the destroy method. And so if we play again now and we're messing about in our desert map, at the end of the timer, we should see it's destroyed and reset, ready for the next round. So now we have got a fully working round system, but there's not really any feedback to the user. Sure, we've got this output here, but you can only see this inside Studio. The players aren't going to be able to see this themselves. So in order to get some of this information from the server to the client, well, we're going to want to have some UI for ourselves. So we're going to go to Starter GUI. We're going to add in a ScreenGui. And I'm going to add in a text label. I just made this one earlier. It just goes right at the top of the screen here. And if I type in a bunch of text, there it is. This is using the Highway Gothic font. It looks pretty good. So I'll just keep it empty for now. We don't need to keep any text in there. And I'm just going to add in now a local script. One more thing, I should probably check that the ScreenGui, you'll notice it has this property called reset on spawn right behind my head. And we're going to want to uncheck that. There we go. And so now we're inside our client script. And first of all, let's go and we're going to get to the GUI itself, local GUI equals script.parent. And we're going to want to set the status of the GUI dot txt status.text, as I've called it, equals, game is starting soon. But we don't have any more information about what's happening on the server. So in order to get that information across, we could use remote events, but actually we're just going to use attributes. So let's create a bunch of attributes in our code and set them to the workspace. So if I go into my countdown function, well, what I can do, instead of just printing it out, I can say workspace set attribute clock and set it to the current value of I. Then inside the intermission function, instead of just printing out intermission, I can say workspace set attribute status, and I'll set that to intermission. And then I'm going to copy that, and then inside the run game function, we'll set the status equals game. And then inside our while loop, we're going to we'll set status down here just after the intermission, and we'll call this loading map. And then here, where we're printing out waiting for players, we'll make it waiting for players, ... And let's add some ... here. Why not? So now we've got all these statuses and these attributes. When we've got two attributes, a status and a clock, we can access them from the client nice and easy. So we're going to create a function for ourselves on our local script called update status. And we're going to want to run this function whenever those attributes change. So workspace get attribute change signal clock, and we will connect it to a function, which in this case is update status. And we're going to want to do the same thing whenever the status attribute changes too. And then when we're running this function, we want to check, well, what actually is the value of the status and what's the value of the clock. So local clock time, oh, can't spell that. Clock time equals workspace get attribute clock, and local game status equals workspace get attribute status. Now, if the status is the intermission or the game, then we're going to have a running clock. So let's check. If game status equals game, or the status is the intermission, then in that case, we want our text. We don't want it to say starting soon. We want it to say something like game status, and then maybe a colon, space, and these ... allow us to add strings together. So game status is a string. It's going to either say game or intermission, and then we want the actual value of the clock attribute. Now, if it's not the game or the intermission, then that means it's going to be saying something like loading map. So in that case, we just want to set. So else we will set the GUI text status.text simply equal to that game status. So pretty straightforward. We're just going to set that value to whatever the status is. Let's give this a play. So here we go. We're counting down 3, 2, 1. And when we get in the game, loading, and we got that game countdown. Pretty nifty. And when this runs out, 4, 3, 2, 1, and we're back in the intermission. And of course, if I set that that player count back up to 2, for instance, then we're going to see waiting for players, or we should do. Why don't we see it? Oh, we don't see it because it's not updating in time. So make sure we call the update status function to begin with as well, like so. So now there we go. It's updated already at the beginning, and it's going to keep waiting. and then if another player was to join, it would start the intermission clock. So there we go. That is our fully working round-based little game. In the next episode, I'm going to show you how we can add a voting mechanic onto this, so you can actually choose what level you have rather than it being fully randomized. But hopefully this helps you with making your next game. If it does, then be sure to leave a like. Let me know down in the comments what you might use this for, and of course, be sure to subscribe. But until the next video, goodbye!